lesson 1.4 takes us kind of a different route, okay? We are working with functions and some various, I don't know if I want to say notation, but some various function-related things. So, first thing you see up there, combination of functions. And on the left there are essentially 4 different, I don't know if I want to say rules, but things that you are allowed to do, okay? So, if you are asked to add 2 functions, it's just saying you just, if it asks you to do f plus g, then you take f of x plus g of x, you add them. Same thing is true with subtraction. If you're asked to do f g of x, so f times g, then yes, you just take the 2 separate functions and multiply them. Same is true of division. So nothing too fancy. So in example 1, we're given f of x and g of x as our 2 functions, and we're asked to find all 4 different operations. So f plus g, f minus g, fg, and f divided by g. So nothing too fancy right here. The fancy ones happen in the homework, I'll tell you that. Okay. F plus g.
Wouldn't you just take x squared plus the square root of x plus 1?
Okay. X squared plus the square root of x plus 1. Does that clean up any? It's a square root, right? Can we add an x squared and a square root?
No.
No, you can't. So f plus g is just that, x squared plus the square root of x plus 1.
Hear me out.
What about f minus g?
Hear me out. Crazy thought, right? X squared minus the square root of x plus 1.
Okay. X squared minus the square root of x plus 1. Can we clean that up at all?
No.
No. Okay. If I get a chance, I'm trying to remember. I know there's some probably cleanup or whatnot in the book, possibly, in the homework problems. I'm not remembering exactly what it was off the top of my head. But the idea is just realizing you can do this. FG.
Would it just be x squared square root of x plus 1?
Yeah. X squared, square root of x plus 1. And again, there's nothing to clean up there. We can't take the square root of x plus 1. So we stop there. What about f over g?
Hear me out. Not that I want to do all of these, but x squared over the square root of x plus 1.
You guys with them?
Yeah.
Okay. F is x squared divided by g, which is the square root of x plus 1. Now, in my notes, I'm going to let you get away with leaving it as is. What technically might you have to do given a certain situation, a specific situation?
Simplify.
Simplify how? What's the catch?
Oh, wait, which one?
On the one we just did.
No, you might have to divide the numbers, or constant, or you know what I'm talking about. Divide certain numbers, like if there's an x on top and an x down low, you might have to cancel.
Okay, and I can't do that on this one, but what I'm trying to ask here is what could be considered illegal about the part on my left?
A negative! Exponent. Is that what you're talking about?
Stop. I'm focusing on the specific answer.
Okay.
X squared over the square root of x plus 1.
I'm with you.
What are we not necessarily allowed to leave in math?
The square root on the bottom.
Square root cannot be left on the bottom, in the denominator. Now, sometimes as we get in upper level math, they do let us do that, is what I'm saying. Okay? So I am leaving that square root for, and in homework, I've seen some answers where there are square roots in the denominator, and that's fine. Okay? Okay. Moving on to composition. Okay. Compositions of FOG, or composition of functions, is FOG, GOF, when you're composing 2 functions. So first of all, it has that little open circle. It's not a multiplication circle, it's a little open circle. And this represents f composed with g of x. Okay, you'll hear me say FOG. But f composed with g of x, By definition means this is f of g of x, where g of x is on the inside and g is plugged into f. So notice the scenario, it's you plug the entire inside function into the outside function. Now, in our example here for this one, we're given f and we're given g. And we are asked to find fog and Goff. So let's start by finding f composed with g of x. You can choose to do this or not do this, but if it's f composed with g, this means we're doing f of g of x. What's that look like in this scenario? F of g of x. What's going on the inside?
Square root of x.
Square root of x. So you can think of this as f of the square root of x. Okay? We can think of it that way. And the idea here is now, since g of x is on the inside, we're going to rewrite f, but in f, every time we see an x, we're going to replace it with square root of x. So what's f supposed to be?
E to the x.
E to the x. So instead of saying e to the x, we're going to say, what goes in place of x?
E to the negative square root of.
Okay, instead of e to the x, it's e to the square root of x. Okay?
Is that the answer?
That is your answer. That is your answer for f composed with g of x. Okay?
I got it now.
Now, let's reverse this. They also ask us to find what I refer to as Goff, g composed with f of x. So we change this and we put g first. Remember, g of f of x means it's going to be g of f of x. So what's going on the inside this time? F of x is equivalent to what?
E to the x.
E of x, or e to the x. So this is going to be g of e to the x.
E to the x.
Meaning, what are we going to do? We're going to take this f.
See an x in the g equation, you replace it with e to the x.
Okay, so we're going to use g. X's become e to the x. So g is supposed to be the square root of x. So what are we going to do instead of the square root of x?
Square root of e to the x.
Okay, it's still square root, but we're replacing x, and we're replacing it with e to the x. So it's going to become the square root of e to the x. And this is your g composed with f of x, or Goff. The point here I want to make, order makes a difference, yes?
Yes.
Okay? Whether it says f of g of x or g of f of x, those are not the same thing. And so you have to be very careful and be very aware of that. Okay? Okay. Questions there? Okay. We're going to be able to continue a little bit here in the same process. Our next section focuses on domain. Okay, or domain. Is it just domain or is it domain and range? Just domain. Okay. Now, with this in mind, folks, watch your directions in homework. It kind of varies. There are several sections that ask you to talk about domain. Okay, like the first section might ask you to talk about domain, if I recall. I don't remember 100%, but watch for that. So, as we talk about finding the domain, the first thing they want you to do is find whatever you're being asked to find. Okay, so in this case, we're being asked to find the domains of fog and goth. So I'm going to start by finding fog. So f composed with g of x. Remember that can be rewritten as f of g of x. Okay. And I don't know how much you guys want me to write out or not write out, but f of g of x means I'm going to take g and put it into f, yes?
Yes.
I'm going to take g and put it into f. So what is g?
Square root of x.
G is the square root of x. So what that says I'm doing is I'm going to take square root of x and I'm going to put it into f. What is f supposed to be?
X squared minus 1.
X squared minus 1. So instead of doing x squared minus 1, what am I putting in place of x?
Square root of x minus 1.
Okay, we're going to do the square root of x squared minus 1. Yes? Which,
Case we root squared.
okay, this is a tough one to,
Change the rule.
well, okay. I agree that it is the square root of x squared is equivalent to what?
X.
X. However,
No.
we have to be careful here because the next thing we're being asked to find is domain.
So it changed the graph.
And so it's going to change what can and can't go into this problem. And that's what we have to be careful of here, okay? So I'm actually going to leave fog, f composed with g, as the square root of x, quantity squared, minus 1. Not arguing that it does simplify to be x minus 1. I agree.
How are you going to simplify
When you're
Well-
putting in the domain.
And here's the deal.
that? Are you ever going to simplify that?
I can go ahead and simplify this. But I need to be able to look back. See, our job is to find the domain. Like, that's our main goal right here. Okay? So I need to be able to look at the pieces. Where are we at here? So let's talk about domain here. This domain is the whole idea of what I'm supposed to be finding. Domain refers to the what values?
X.
The x values. Okay, so generally speaking, how far left does my graph go? How far right does it go? Those type of things. But specifically, we've talked about two specific things with domain. We've talked about denominators and we've talked about square roots. Yes? Well, do I see any denominators?
No.
No. Okay. Just remember denominators cannot equal 0.
Yeah.
Do we see any square roots?
Yes,
Well,
we do.
if you look right here, before we simplified it, there is a square root, isn't there? What do you remember about square roots? Whatever's under the square root must be what?
Greater than 1 or 0.
Greater than or equal to 0? Because the inside of a square root cannot be negative. So what's under my square root here before we squared it?
Positive number.
Well, x.
X.
And so what's x have to be?
Greater than or equal to 0.
Has to be greater than or equal to 0. So with that in mind, I think I'm going to make this a little bit bigger so we can, with the fact, and that's why I didn't want to totally get rid of the square root. Because if you totally get rid of the square root and you just see x minus 1, we're going to say, oh, it's all real numbers. But it's not because of this square root. Okay? And so this is where we can't really look at the graph. We have to think about the equation. Now, x greater than or equal to 0. How do you write that in interval notation?
Bracket 0, comma.
Okay, so greater than or equal to 0 is 0 and everything right of it. So 0 to infinity. We did say equal to, so bracket. And infinity always uses parentheses.
Boom.
Okay? So there's the domain I'm looking for on that one. So our domain rules from lesson, I think that was the beginning of 1.2. They haven't left us. They still exist. Now, that was the first half of the problem. Because it was find the domain of fog. We did that, and now we need to find the domain of
Golf.
golf. So G composed with f of x. Well, in order to find the domain, we need
That's all good.
to do some, we have to find golf. So remember, G composed with f is G of f of x, right? Are we starting to catch on to how we do this?
Yeah.
I should say catch on because we did this in Algebra 2. Are we starting to remember how we do it? Is that a better way? So G of f of x. F is going into G. What is f?
X squared minus 1.
So in place of f, I put x squared minus 1.
Yeah.
What are we saying here now? X squared minus 1 is going to go into
G's.
G. So every place you see an x, what is the equation G?
Square root of x.
Square root of x. Except what is x now?
X is now x squared minus 1.
X squared minus 1.
Boom. Bada bing.
Okay.
And then x is also greater than or equal to 0.
So here, this is golf, G composed with f of x. And we need to talk domain here. We need to talk domain.
X, what you got for us? Well, yeah, we did one.
Okay, domain. Got two things you need to be looking for. Do you see either of them?
Yes, I got one. Actually, you know one? No. Alright.
What do you see, Logan?
I see an x under the square root, which
Okay,
means x is either greater than or equal to 0.
not exactly.
Close.
Okay, so here's the deal. Any denominators? No
No.
denominators, but there is a square root. Whatever is under the square root is greater than or equal to 0.
Okay.
So not just that one piece. We're going to say x squared minus 1 is greater than or equal to 0.
I did not know that. Is this where we solve?
And then we're going to have to do some solving to figure out what's going on with x. If x squared minus 1 is greater than or equal to 0, then x squared is
Greater than or equal to 1.
greater than,
Right. Plus
we're going to add 1, and I have x squared is greater than or equal to 1. Yes?
Yeah.
Now, when you go to solve that, well, the square root of x squared is x. The square root of 1 is plus or minus 1, but then we have this catch of this was a greater than sign.
Would you flip it?
And if it's a greater than sign, Paxton's going to sigh and show his annoyance, okay? So I know he catches on to what I'm saying.
I'm still lost.
Greater than means what kind of statement am I going to
What are we
make?
doing?
This is an or statement. So this is going to be that x, keeping the sign and the positive value, is greater than or equal to 1, or x is, what do you do with the other one?
Minus.
You switch the greater than to less than, and it's negative 1. Okay?
Oh!
So when you take that square root, because here's the deal, guys. We square root this, you have x, you have plus or minus 1, but that sign's kind of, you can't really put both signs in there. So that's why we have to write two statements. Okay? How do I write this in interval notation?
Is this unionization?
Yes.
So hear me out. We're going to go from what looks to be, we'll say negative infinity to negative 1.
Are you making a
And then we're gonna go from 1 to infinity. We're unionizing.
What are we using with -1 and 1?
Would those be brackets?
It was greater than or equal to and less than or equal to, so they are brackets.
What are brackets? That's how they answer, right? What game show is that?
What is
Jeopardy.
What is, yeah. What is?
What are, what is?
Yeah. What is brackets?
Okay. Domains. They're going to take a little bit of work. Okay. I'm sure we're going to have some questions to talk about on Thursday. But work to see what you can do with domains. Okay.
And you said these are the easy problems?
These aren't too
I don't remember what kind of domains are in there, to be honest.
complicated.
As I said, some of the homework are easy parts. There are some more difficult parts of homework that, if I recall, we will probably have to talk about. So,
PVC.
okay. So, in order to find the domain there, we just compose functions. When you do fog and goth, that is function composition. When you do f of g of x, g of f of x, that is function composition. Now we're going to do the opposite. We're going to decompose.
Okay.
Okay, so hold on. To decompose a function, basically we're taking something like f of g of x or g of f of x, and our job is to separate it into, okay, what was f of x? What was g of x before they were composed together? So we're trying to work backwards here. So you'll notice to decompose a function to two composed functions, one of the ways I'll try and explain it is you want to find the inside function, like what can we pull out that was put into the function? What can we pull back out? So find that inside function, and then what remains, what is that outside function? Okay, so for each of these functions, they're calling them h. My job is to find f and g based on that setup right there. Based on the fact that this is f of g of x. So that means that g is the, in this scenario,
What's been added into the f?
yeah, g of x is your inside function. And if you want, you can think of f of x as your outside function. So easiest thing to look for, though, is what do you see that got put into another function? Okay, so I'm going to suggest we try and find our inside function, and then that we try and find our outside function. Okay, have you had a moment to look at it? I've had several moments, but I've been talking. But do you see something that you think could be the inside function? Okay. Okay, go ahead. What do you think, Logan?
I'm gonna say x plus 1 just because it's kind of repeated.
Okay, so first of all, the fact that something is repeated, it won't always be repeated. But the fact that we see something repeated, that is a clue. Okay, so the idea here, what I would use on the inside, which what was going to be our inside, that is g of x in this case, is x plus 1. Now, if g of x is x plus 1, we need to find our outside, which is f of x, and here's the deal. If you take the x plus 1 out, because keep in mind, what would x plus 1 have been put in place of?
X.
It would have been put in place of an x. So if you take those x plus 1s out, and now what's going to go in their place is an x, what do we think our f of x, our outside function, is? What do we think there?
Do you want an answer? We don't give you an answer.
I'll take an answer.
I'll just kind of give everybody else a chance. I got x squared minus x plus 4.
And I would take that. That's what I would. Okay. the idea, folks? When we took these x plus 1's out, what goes in their place is x. Okay, and that's how you get the x squared minus 3x plus 4. Because that x is going to go in the place. Now, I will tell you, there's not always just one right answer. You could come up with a different combination of g of x and f of x at times. But the reason I made Logan slow down and not just fire off an answer in this one is I need you to stop and think for a moment before we do one, right? Because once the answer's said, it's hard to see it on your own. And that's what I need you guys to get in the progress of, is trying to see it on your own. Okay. Do you have questions I should answer there?
Yeah, so why are we decomposing a function into two composed functions? Now, not that I'm wondering, but
There's purposes for it.
when a decomposing...
You're trying to pull it back apart. So there's purposes where it's useful. Right now it's just kind of learning the skill. Okay, let's try h of x.
Attaboy, P. Diddy.
Now, everyone think on your own. Because I could very much argue that there are two sets of possible answers here. To me, there's what I would call the obvious answer in my brain, but I've definitely had people come up with other answers. Okay, I just realized I have a mistake in my notes. Okay, so thoughts on what you might use as the inside function? What might you see as the inside function? Okay.
See, I was thinking that, but then there's no parentheses.
There's not always going to be parentheses. Okay. I can agree that our inside is x cubed plus 1. Now, if we go this route and we use x cubed plus 1 as our inside, what does that make? What did we plug it into? Okay. So if you go that route, the idea is that x cubed plus 1 comes out, and that was put in place of an x. This is one combination of answers. It's not the only combination of answers, though. Okay? And that's what when I quiz or a test or something, what I'll always do is I'll look at your answer. If it doesn't agree with my answer key, I'll try and put it back together. I'll compose it and see if it works. If it works, you get the point. If it doesn't work, sorry. But I'm always willing to try. Now, with that in mind, I don't know if it's good or bad, but I want to talk about one other option that I see of what we could use for a g of x combo and f of x combo. So, what's another option that we could possibly use here? What were you going to say, Logan?
I was just going to say that the inside was like x cubed, and then the outside was x plus 1. Square plus 1.
Yeah. Okay. So another option is if we just use x cubed as the inside, where you just pull. To me, this is kind of the not as obvious answer, but it works. Okay. If I just use x cubed, so here's x cubed. Now, what would x cubed have gone in place of? It would have gone in place of an x. So that makes this over here the square root of, if I put an x there, x plus 1. Here's the idea. If I compose that, it works. Am I saying these are the only two answers? I'm not. I'm not going to make that statement. Okay, they're the two obvious answers to me, but I'm not going to say they're the only options. Okay? Okay. Questions I can answer there. Does take practice. Let me know how I can help on those, okay? Okay, we got one more problem to do. That's on the back. Well, one more. It's a part ABCer, but you know. Okay. In the medical procedure, angioplasty, a catheter is inserted into a heart vein in order to inflate a small spherical balloon. Suppose the balloon inflated at a constant rate of 44 cubic millimeters per second. Now, they ask us to do some things. They ask us to, first of all, find the volume after t seconds.
So wouldn't it just be like 44 millimeters cubed times t?
Maybe.
Because it's 44 millimeters?
Yeah.
Millimeters cubed, right? Per second, which means we're just trying to find after how many seconds, t seconds, and we're just multiplying it by that per second.
Okay. So 44 cubic millimeters per second. First of all, when you hear volume, what kind of label does volume have? Volume has the 3, yes? The cube. So when you see millimeters cubed per second, what is that indicating that 44 is? That's indicating it is a volume. Now, it says per second, so my train of thought is, okay, what do you know about the volume after 1 second?
It's 44 millimeters.
After 1 second, my volume is 44 millimeters cubed. What about after 2 seconds? What is my volume? 2 times 44, so now it's 88. So what about after t seconds? Because that's what the question asks us, right?
44 millimeters.
Yeah. And we don't even necessarily need a label, but the idea is after t seconds, it is 44 times t. So yes, the volume after t seconds is 44t because it's 44 cubic millimeters per second. Okay, and I'm using what I know that volume has a cubic label. And I see a cubic label, so that's shouting out to me, I'm volume, okay? Okay, B. Turn your brains on. B says, when the volume is V, what is the radius? Now, in order to talk about how volume and radius are related, we need a formula. We didn't need a formula to do A. We just had to use what the problem gave us. In order to do B, we need a formula. Now, volume. What shape are we talking here? Okay. A spherical balloon, so a sphere. Do we know the volume of a sphere?
Not gonna lie.
R squared.
Not squared. We're in volume.
R cubed.
Cubed. Mm-hmm. Nice. Okay. 4/3 pi r cubed is volume of a sphere. Okay. Now, am I expecting you to automatically know that formula in a test? No. Okay. You expect me to be neat. Is that what you want?
Not
Okay.
really, no.
Now, it says when the volume is V, what is the radius R? Your job is to take this equation and solve for R. What would you like to do to solve for R? Not yet. Because right now,
Yeah, no, well, I wasn't thinking that.
not yet. Hold that thought. I think that we'll talk about that on part C. Okay? Right now, I just want to know when the volume is V, so we want to leave it in terms of V for the moment. How do I solve for r and get r by itself right now?
You know 4/3 pi.
Okay, now, dividing by 4/3 is the same as multiplying by what?
3.
3/4.
3/4. Yeah.
I'm going to start off multiplying both sides by 3/4. So 3/4 times v is 3/4 v, or how about if I say 3v over 4?
Sure.
Either or, equals 3/4 times 4/3 will
Cancel.
cancel,
Bang. Out of here. Over and over.
and I have pi r cubed. Divide by pi. Now I'm going to say I should have taken it when I took the other one. Dividing by pi is multiplying by,
Negative.
no,
Oh wait, hold on.
dividing by pi over 1
Yeah.
is multiplying by
1 over.
1 over pi. And I'm just doing that because I already have a fraction on the left. I'm trying to make it not get too messy. So now, this becomes 3v over 4 pi. 1 over pi times pi cancels, and I'm left with r cubed. How do I solve for r? It's r to the third, so we're going to take the cube root of both sides. What you do to one side, you do to the other. And so now the cube root of r cubed is r. The cube root of 3v over 4 pi, you got it. Okay.
Yeah, that was really complicated.
Okay. A was easy. B took some thought. C. Write an equation that gives radius as a function of time. What is the radius after 5 seconds? So hold that thought. We'll do that later. But write an equation that gives radius as a function of time. So first of all, I want an equation that says r equals.
You got one.
But I want my variable in it to be t. I want it to be as a function of time. Now,
So you just, it would be 344t instead, right? Or it'd be, well,
No way, it's that simple. It's not that simple.
it'd be like 100-something t.
okay. So our r equals equation comes from part B, yes? But I don't want it in terms of v. We were told to have it in terms of t. Well, what do we know about v and t?
V equals 44t.
And this is where, Noel, when you said plug that in, I said hold that thought.
It is that simple.
We're going to plug it in. So now, when I rewrite this, r as the cube root of 3 instead of 3v, I'm going to say 3 times
44t.
44t
And then that's.
over 4 pi.
Oh my goodness.
Now,
It's that simple.
I'm going to do some canceling before I multiply. What do you see in that fraction that can cancel?
It can be made to 11t and
Yeah.
pi.
4 and 44 both divide by 4. 4 divided by 4 is 1. 44 divided by 4 is 11. And really what I'm doing is I'm just not having to get my calculator out at this moment. So the cube root of 3 times 11t is
33t.
33t over pi. So there's the first part. Write an equation that gives the radius of r as a function of time t. Now, what is the radius after 5 seconds?
5 and 14.
Yep. We're going to use this equation we just created. R equals the cube root of 33 times 5 divided by pi. grab your calculators and practice using them.
How do you do cube roots?
Is there a button for cube roots, or do you have to go? I don't think there is there?
I don't think there is. I see squares.
Okay, so
Calculator.
options for cube roots.
Go to math.
There's something in the math menu, or
I
it's
see
also in the Alpha F2 shortcut.
That's 3.
Am I right on the Alpha F2 shortcut?
Alpha F2.
Like it's in a shortcut
Yeah.
there.
I
So
think it's
Alpha
up to
F2, it's number 6. Or in the math menu,
It's pi.
it's number 5. Or there's number 4, which is just a cube root. Are you guys figuring that out?
Yep. Are you wanting some answers?
I will take some answers.
How many decimals are we running?
I have 2 decimals on my final answer.
3.74.
Okay. Yep.
Millimeter. Would it be millimeters a second?
3.74.
To measure distance.
Yeah.
This is a radius. Radius is a distance, so I just want
That.
Millimeters.
millimeters. Okay. This was originally 3.7449
3850. Too many numbers.
38504.
Relevant.
Okay.
Good to me.
Okay, guys. Your homework: 2 through 8 evens, 12 through 30 evens, and 31. This is due on Thursday. So you have 2 assignments to get done in the next 48 hours.
It's gonna be nice being here
Okay.
to work on it.
So make sure you get that done.
Looking for Paxton. Where's P1?